Today we are going to continue to talk about the tangent line problem. By the end of this video, you should be able to use the power rule to find the first derivative of a function, and you will be able to write the equation of tangent lines to functions at certain points. So, first, when the directions tell you to use the formal definition of a derivative or the limit definition of a derivative, you need to show all of your work and use the definition that we discussed in the last video. The derivative, f prime of x, gives you the slope, and you find that by doing the limit as h approaches 0 of the difference quotient, which is f of x plus h minus f of x over h. Any other time that you need to find or use a derivative, you may use the power rule method. So let me explain what the power rule is. If you have a function here, we have f of x equals 5x cubed minus 4x squared plus 3x minus 11. To find the derivative using the power rule, we are going to take the exponent, multiply it with the coefficient, and decrease the exponent by 1. So to find the derivative, I'm going to take the exponent, multiply it by the coefficient, so 3 times 5 is 15, and decrease the exponent by 1. So x squared. And I'm going to continue with all of the other terms. So if I have 2 times negative 4, that is negative 8, decrease the exponent by 1. 1 times 3 is 3, decrease the exponent by 1. And 0 times negative 11 is 0. So if I clean this up, I have f prime of x equals 15x squared minus 8x plus 3. You could verify this by using the formal definition with the limit as h approaches 0 of the difference quotient, but this is the shortcut. It is called the power rule. As a reminder, if you are trying to write the equation of the tangent line, point-slope form is the best way to do that. Remember that point-slope form is y minus y1 equals m times x minus x1, where m is your slope and the point x1, y1 is your point. Let's take a look at an example. First, we have let a of x be a function defined by a of x equals x squared minus 2x minus 2. Find an equation of the line tangent to the graph of a of x at the point where x equals 3, and graph both a of x and the tangent line. I'm going to start by graphing a of x. Since a of x is in standard form, I need to find the vertex. You find the vertex by doing negative b over 2a to find the x value, and then you plug that x value into the function to find the y value. So in this case, our vertex, we would have negative b, so negative 2, over 2 times 1. So that is just 2 over 2, which is 1. If I then plug 1 into my function for x, I end up with 1 minus 2 minus 2, which is negative 3. So 1, negative 3 is my vertex. Since the a value of this function is 1, I'm going to go over 1, up 1 on both sides, over 2, up 4 on both sides, and then over 3, up 9. When I connect these points, I will have my parabola. Now, we want to find the equation of our tangent line. The first thing we need to find is the slope. To do this, we need to find the derivative. So using the power rule, I'm going to take my exponent, multiply it with my coefficient, and drop the degree so I end up with 2x minus 2 as my derivative. To find the slope when x equals 3, I need to plug in 3 to my derivative. So I end up with 6 minus 2, which is 4. Then I need to find my point. To do this, I just want to plug in 3 for x in the original function. So I end up with 9 minus 6 minus 2, which is 1. So my point is 3, 1, which is here. Now I need to write the equation of my tangent line, and I'm going to use point-slope form. So I have y minus the y value of the point, which is 1, m, which is my slope, and then x minus the x coordinate of my point. So this is the equation of the tangent line. To graph the tangent line, we're going to start at our point, which is 3, 1, and then just count out the slope. Our slope is 4, so we go up 4 over 1. And that's our graph. Next, we have that b of x is a function defined by b of x equals 4x cubed minus 5x plus 3. We want to find the equation of the tangent line at x equals negative 1. So, to find the slope, we need the derivative, b prime of x. So I need to multiply the coefficient and the exponent, decrease the exponent by 1, my derivative is 12x squared minus 5. To find the slope at negative 1, we need to plug in negative 1 for x, and I end up with 7 as my slope. To find the point, I just need to plug in negative 1 for x in the original function, so I end up with negative 4 plus 5 plus 3, which gives me 4. So my point is negative 1, 4. Then when I write my equation, I have y minus y1, which is the y-coordinate of my point, equals m, the slope, times x minus x1, which is the x-coordinate of my point. So I have x minus -1 or x plus 1. And that's the equation of my tangent line. Remember, it is totally acceptable to leave your equation in point-slope form. You do not need to rewrite it in slope-intercept form. Next, one of the big concepts in calculus is finding where a function has a horizontal tangent line. Remember that horizontal lines have a slope of 0. These will tell us the maximum and minimum points of a function. So, we need to start by finding the derivative of our function. Again, we're going to use the power rule. Take the exponent, multiply it with the coefficient, decrease the exponent by 1, so our derivative is 3x squared plus 12x minus 15. We want to know where the derivative equals 0. So we need to solve this equation, 3x squared plus 12x minus 15 equals 0. I'm going to start by factoring out a GCF, which is 3. And then factoring this trinomial. I need to find two numbers that multiply to -5 and add up to 4, which is 5 and -1. So then I end up with x plus 5 equals 0, x minus 1 equals 0, so x is -5 and x is 1. Now, these are just the x values where there is a horizontal tangent line. We want the actual points. So to find the points, I need to do e of -5 and e of 1. So if I plug -5 in for x, I get -125 plus 150 plus 75 plus 1 is 101. Then e of 1 1 plus 6 minus 15 plus 1 is -7. So the points where I have horizontal tangent lines are -5, 101, and 1, -7. Let's look at one last example. I want to find the points where this function has a horizontal tangent line. Now, this is a rational function, not a polynomial like all of our other examples. But we can rewrite this and still apply the power rule. If you remember your properties of exponents, this is the same as 2 times x to the -5th. Now that we have this written in a different format, we can apply the power rule to find the derivative. We are still going to multiply the exponent and the coefficient, and then subtract 1 from the exponent. So I end up with the derivative is equal to negative 10 over x to the 6th. Again, since I want to know where there are horizontal tangent lines, I want to know where the slope is 0. So if I solve this, I need to multiply both sides by the denominator, which is x to the 6th, so I end up with negative 10 equals 0. Well, negative 10 does not equal 0, which means that there are no horizontal tangent lines.